Okay, we're going to talk about now how to solve second-order linear homogeneous differential equations with constant coefficients. We've added enough adjectives in here that these are the easiest type of second-order differential equations. Okay, so what kind of equation is this? Well, let's see. We have a y double prime, and then we can have constants. So let's say, for example, minus 8y prime plus 15y equals 0. Okay, and we've seen that the exponential function e to some power comes up pretty regularly. So maybe we're going to try this guess and check approach, which is actually a pretty common approach in differential equations, because otherwise it's too hard. So we're going to try y equals e to the rt, where we'll leave r will maybe depend on these constants. Okay, so let's just check that. Well, then y prime is r e to the rt, and y double prime is r squared e to the rt, right? So if we plug all that into the equation, this is very out of focus. Okay, we can see all of this. Then we can maybe solve for r. So let's try that. Y double prime is r squared e to the rt minus 8. Y prime is r e to the rt plus 15. Y is e to the rt equals 0. And then we can factor out an e to the rt out of everything. R squared minus 8r plus 15 equals 0. And we know that everything that's e to some power is greater than 0. So if this is greater than 0, then this other thing must be 0 if the two multiply to 0. So we get this. R squared minus 8r plus 15 equals 0. And this, by the way, is called the characteristic equation for this differential equation. When you solve these on homework and on quizzes, because once we've done this once, you don't have to do this again. We don't have to do any of this. We know we're going to try y equals e to the rt. We know when we take the derivatives, however many derivatives we take, we'll get r to that power. So you can skip from here to here. You can read this right off. Y double prime, you're going to replace with r squared. So any derivative will replace with r to that power. Okay, and we know the solutions are going to be of the form y equals r e to the rt. So we just showed you this to see the motivation for how to get here, but from now on you don't need to do that. This is a quadratic that factors, so that's easy. If it doesn't factor, you can use the quadratic formula. So then we get two numbers multiplied to give you 0. One of them must be 0. R minus 5 equals 0, so r equals 3, or r equals 5. This means back in our original equation, y equals e to the 3t, or y equals e to the 5t. Okay, we have not taken advantage of the fact that our differential equation is homogeneous. And we talked in the last lecture about how homogeneous meant y equals 0 is a solution. That was a good thing that homogeneous meant. But it also means that if you multiply, if y is a solution, remember this from a few weeks ago, then ky is a solution for any multiple k. Because if you plug that in, then you just get a factor of k in every term. So if this thing equals 0, then of course k times this thing equals 0. And also, if y and y1 are solutions, so is y plus y1. If you've got two different solutions, you can add them together. Check that out, because then when you take derivatives of a sum, it's the sum of the derivatives. So then you get the differential equation separated out twice in terms of y, and then plus the same thing in terms of y1. 0 plus 0 is 0. So what we can do is we can look at our guessed two solutions and come up with a general solution, which is y equals a times e to the 3t plus b times e to the 5t. That's going to, in general, be a solution. And there's two constants here, which we'll talk about in a minute. if you don't believe me, because maybe this was a little bit hand-wavy, let's just check it. Let's just check. So we're actually going to do some arithmetic. We're going to take y prime, which will get 3a e to the 3t plus 5b e to the 5t, right? And then we're going to take y double prime, which is 9a e to the 3t plus 25b e to the 5t. And we're saying that we need y double prime minus 8y prime plus 15y is hopefully 0. That's the left-hand side. Let's check if it's 0 with this general solution for y. Okay, well, y double prime is 9a e to the 3t plus 25b e to the 5t minus, we need 8 times this, so we'll subtract 24a e to the 3t minus this 8 times 5 is 40, b e to the 5t, and then plus 15 times the original, 15a e to the 3t plus 15b e to the 5t. And let's check it out. We've got 9a e to the 3t minus 24a e to the 3t plus 15a e to the 3t. Well, 9 plus 15 is 24, minus 24 is 0. And then same thing with the b's. We've got 25b e to the 5t minus 40b e to the 5t plus 15b e to the 5t. Well, 25 plus 15 is 40, so that cancels out with that one. So this does, in fact, equal 0, which means it equals the right-hand side. So this general solution, if you didn't believe me before, now you do, works. Okay, there's two constants. What does that mean? That means we need two initial values. And we can't really say like y of 0 equals something and then y of something else equals something else. So what we're going to do, for example, we'll give an initial value for the original and we'll give initial value for the derivative. So that's like saying, if this is some sort of motion in physics, that's like saying the initial position and the initial speed, and then we're off with some sort of force that gives us an acceleration. Okay, so let's solve this initial value problem consisting of those initial values and the original equation. Let's do that on another page. So then we've already solved our general solution, which is y equals a e to the 3t plus b e to the 5t. So we just need to plug in the initial values. Y of 0 we said was 1. But y of 0 is also a times e to the 0 is 1 plus b times e to the 0 is 1 equals 1, we said, is the initial value. And then we need y prime. Let's just write down what y prime was. We've already solved for that. That's 3a e to the 3t plus 5b e to the 5t. And then the initial value, I'll just write down the initial values here so you don't think I'm making them up. Y of 0 is 1, y prime of 0 is 2. So we'll plug that in. Y prime of 0 is 3a times e to the 0 is 1 plus 5b times e to the 0 is 1, and that equals 2. So we've got these two equations. We need to solve for a and b. We're going to take 3 times equation 1. I like elimination for these. You're welcome to do substitution if you prefer. Plus 3b equals 3. It's equation 3, and we're going to do equation 2 minus equation 3. So the a's will cancel. We get 2b left on the left. 2 minus 3 is negative 1. b is negative 1/2, and then from equation 1, that means a is 1 minus b, which is going to be 1 plus 1/2, which is 3/2. So the solution to this initial value problem, we actually get an exact function with no more constants. 3/2 e to the 3t minus 1/2 e to the 5t.